Hi everyone. In today's video, you will learn how to construct and test an up-down synchronous decade counter using IC 74LS190 and monitor the output on LEDs.
At the end of this video, you will be able to construct an up-down counter using IC 74LS190. Test the counter for counting up and counting down. Let us collect all the tools, equipment and materials required to do this practical. Digital trainer kit with user manual, IC 74LS190 with datasheet, male-to-male jumper wire, magnifying lens. Let us discuss the up and down synchronous decade counter. In an up counter, count sequence progresses in ascending order, moving from the lower to higher numbers. Example 0, 1, 2 up to 9. When a clock pulse is applied to the counter, it advances to the next count in a sequential manner. In a down counter, the count sequence progresses in descending order, moving from higher to lower numbers. Example 9, 8, 7 up to 0. Similar to the up counter, a clock pulse triggers the counter to move to the next count, but in this case it decrements the count. Let us discuss about IC 74LS190. The 74LS190 is a positive edge-triggered synchronous up-down binary counter IC that contains 16 pins in a dual inline DIL package. The IC 74LS190 is a 4-bit counter, meaning it can count in binary from 0000 to 1001, 0 to 9 in decimal. Let us discuss the pin details of IC 74LS190. Pin 1 parallel input B, Pin 2 output QB, Pin 3 output QA, Pin 4 active low count enabled input, Pin 5 up down control input, high for down count, low for up count, Pin 6 output QC, Pin 7 output QD, Pin 8 ground, Pin 9 parallel input D, Pin 10 parallel input C, Pin 11 active low parallel load control input, Pin 12 terminal count output, Pin 13 active low ripple clock output, Pin 14 clock input, Pin 15 parallel input A, Pin 16 power supply plus 5 volt VCC. Construction of synchronous up-down decade counter using IC 74LS190. Identify the IC with its part number printed on it using a magnifying lens. Identify pin number 1 of the IC and ensure that the IC 74LS190 is aligned correctly over the breadboard in the digital trainer kit. Gently insert both lines of pins of ICs on breadboard one after the other. Be careful not to bend the pins or force them into the holes. Ensure that the IC is sitting flat on the breadboard without any pins bent or misaligned. Connect the pin number 8 to ground and pin number 16 to plus 5 volt power supply VCC. Connect pin number 14 to the clock input from the digital trainer kit. Connect pin 15 to D0 input toggle switch. Connect pin 1 to D1, pin 10 to D2, pin 9 to D3. Connect the pin 7 to Q0, pin 6 to Q1, pin 2 to Q2 and pin 3 to Q3. The output LEDs in the digital trainer kit. Connect pin number 5 to the toggle switch S1, pin 11 to toggle switch S2 as shown in the circuit diagram. Switch on the supply and apply plus 5 volt regulated DC supply to the circuit. Setting the decade counter to count up mode and test. Apply logic 0 to the control pin 5, that is S1, and logic 1 to pin 11, that is S2, to make the counter count up through a toggle switch. Apply logic 0 to the pins D0 to D3 using toggle switches. Apply logic 0 to the control pin momentarily and raise it back to logic 1 state with a toggle switch S2. This sets output Q0, Q1, Q2, Q3 to logic 0 levels. Refer to the tabulation of inputs and feed clock pulses at clock input to pin number 14 using single shot pulsar. Record the status of LEDs at outputs Q0, Q1, Q2 and Q3. Set logic 0 to pin 5 and logic 1 to pin 11. Clock pulse 1, output 0, 0, 0, 1. Clock pulse 2, output 0, 0, 1, 0. Clock pulse 3, output 0, 0, 1, 1. Clock pulse 4, output 0, 1, 0, 0. Clock pulse 5, output 0, 1, 0, 1. Clock pulse 6, output 0, 1, 1, 0. Clock pulse 7, output 0, 1, 1, 1. Clock pulse 8, output 1, 0, 0, 0. Clock pulse 9, output 1, 0, 0, 1. Thus, we connected the up counter. From the recorded readings, it is observed that the counter is counting up. Setting the decade counter to count down mode and test. Feed the inputs of D0, D1, D2 and D3 with 1001 as binary values using toggle switches. This is equivalent to decimal number 9 as a set input for the down counter. Apply logic 1 to pin 5 such that the counter is now set for countdown operation. Refer to the tabulation and feed clock pulses at clock input pin 14. On feeding each clock pulse, record the output Q0, Q1, Q2 and Q3. LEDs on means logic 1 and off means logic 0. Set logic 1 to pin 5 and logic 1 to pin 11. Clock pulse 1, output 1, 0, 0, 0. Clock pulse 2, output 0, 1, 1, 1. Clock pulse 3, output 0, 1, 1, 0. Clock pulse 4, output 0, 1, 0, 1. Clock pulse 5, output 0, 1, 0, 0. Clock pulse 6, output 0, 0, 1, 1. Clock pulse 7, output 0, 0, 1, 0. Clock pulse 8, output 0, 0, 0, 1. Clock pulse 9, output 0, 0, 0, 0. Thus, we constructed down counter. From the recorded readings, it is observed that the counter is counting down.
Thus, we have constructed up-down synchronous decade counter and tested the operation by observing the output LEDs with reference to the truth tables.
Thank you.